Today, what we're going to talk about is partial fraction decomposition. And I want to look at a problem first and to describe what partial fraction decomposition actually is, okay? So if we take this rational function, 3 over x plus 2 minus 5 over x minus 3, to subtract these, we need to get a common denominator, right? So this one's going to need an x minus 3, and this one's going to need an x plus 2. So this would be equivalent to writing 3 over x plus 2, and then multiply that by x minus 3 over x minus 3, because that's a version of 1, which will get us the common denominator that we need, and then minus, and then 5 over x minus 3. And this fraction we're going to multiply by x plus 2 over x plus 2. All right, because then this will give us the common denominator that we're looking for. So this winds up being equivalent to 3 times x minus 3 over, and then x plus 2 times x minus 3. And then minus 5 times x plus 2 over, and then x minus 3 times x plus 2. And I know the order is different, but these denominators are actually the same, right? Because I could, because multiplication, the order doesn't matter, I could rearrange this and write the first one as x plus 2, and the second one is x minus 3, and then it would match this one, right? So we're ready. These are our common denominators. So what we need to do is now subtract these two numerators from each other. So this winds up being 3 times x minus 3 minus 5 times x plus 2 all over, and then x plus 2 times x minus 3. Distributing the 3 and here distributing the negative 5, that would give us 3x minus 9 minus 5x minus 10 all over x plus 2 times x minus 3. And cleaning this up a little bit more, we have 3x minus 5x. That would give us negative 2x minus 19 over, and then we'd have x plus 2 times x minus 3. And then what I'm going to do next is I'm going to multiply these two together to get a denominator, and that would give us negative 2x minus 19 over, and when I multiply this out, I would wind up with x squared minus x minus 6. Okay, so we did all that just to get this as one fraction, right? So it turns out in calculus, we actually need to go in reverse. If we have something like this, we need to rewrite it and go backwards so it looks like this. And that's going to be helpful in integration. So we need to learn how to go backwards. How do we start with something like this and work our way backwards to the individual fractions that we either added or subtracted together in order to get this one fraction? Okay, so that's what partial fraction decomposition is all about, is starting with this and working our way backwards to get this, because it turns out that this is going to be easier to integrate than this one right here. Okay. All right. Okay, so here we go. Okay, these are going to be, they're called distinct linear factors. So we don't have repeated factors in this. I'm going to talk about what do we do when we have repeated factors in just a minute. But what we want to do is we want to factor this denominator. Okay, so we wind up with 4x plus 2 over, and then when we factor this, we have to think of two numbers that multiply to give you negative 8 and add to give you negative 2. So that'd be negative 4 and positive 2. So this factors into x minus 4 times x plus 2. Okay, and what this gives us is our individual denominators for our two fractions that we're going to either add or subtract. So we're going to rewrite this as a, because we don't know what the numerator is yet, so we're going to call it a, over x minus 4 and then plus b, we're going to call this numerator b, over x plus 2. All right. And what we did here is we factored the denominator and we set up the fractions. Okay. So factor denominator. And set up fractions. And that was this step right here, okay? Because we factored it, now we know, okay, so one of the denominators is going to be x minus 4 and the other denominator is going to be x plus 2. All right. So then the next thing we're going to do is we're going to clear out all of our denominators. So to clear out all of our denominators, we're going to want to multiply both sides of this equation by x minus 4 and x plus 2. So both sides, all right? So that makes this side, I'm going to multiply by x minus 4 times x plus 2. I'm going to multiply this side by that. So this would be x minus, this denominator is x minus 4 times x plus 2. I'm writing it now, like if you just did this mentally, that'd be fine too, okay, when we really start doing these. And this is equal to, okay, so now this is going to be a times the x minus 4 times x plus 2. Because I'm going to have to multiply both of these by that, right? So over x minus 4. And then plus my b over, and I'm going to multiply the b by also x minus 4 times x plus 2. Extend my fraction bar a little bit more, and this would be x plus 2. Okay, so when we're going to multiply to clear out fractions. And we're always going to multiply by this, like the x minus 4 times the x plus 2. Now, what happens is both of these cancel. So we're just going to be left with the 4x plus 2. Equals. And for this first fraction, our x minus 4s are going to cancel. So we would be left with this a, which is going to be the numerator, times x plus 2. And then plus, and for this one, the x plus 2s are going to cancel. So you're going to be left with plus b times x minus 4. And then the next thing we're going to do is we're going to pick an x value that makes one of the factors here be 0. So for this one, we're going to pick -2, or for this one, we pick x equals 4. Okay, so we're going to pick an x value. That makes one of the factors 0. All right, so if we do that over here, okay, I'm going to let x equal 4. Okay, so here, this x is going to be 4, this x is going to be 4, and this x is going to be 4. So we'd have 4 times 4 plus 2 is equal to a times 4 plus 2 plus b times 4 minus 4. And so what that's going to do is it's going to get rid of this b value right here, because this is going to be 0 times b. Right? This is going to be 16 plus 2, so that'd be 18 equals, this would be a times 6, or 6a, and then plus, and then 4 minus 4, this would be 0b, right? 0 times b, which is really 0, right? So this becomes 18 is equal to 6a, and so if we divide both sides by 6, we get 3 is equal to a. We now know what our a value, this a right here, is going to be 3. Okay, now what is this b, right? What is the b? Well, what we're going to do is we're going to let x equal -2, and we're going to get rid of this one. So we're going to let x equals -2. When x equals -2, this left side is going to be 4 times -2 plus 2, and that's equal to a times -2 plus 2 plus b times -2 minus 4. So this would be -8 plus 2, which gives you -6, is equal to, this would be a times 0 or 0a. This would be -6 times b, so we're going to write -6b. And so this becomes 0. So we have -6 is equal to -6b. Divide both sides by 6, and we get 1 is equal to b. So now we know a is 3 and b is 1. All right. So we've broken it up. So that means that what two fractions could I add or subtract together that would give me this original fraction? And so what we now know is that for x plus 2 over x minus 4 times x plus 2 is equivalent, is exactly the same. Let me slide it up for you. Okay, is exactly the same as up here, my a value, which I figured out was 3 over x minus 4. And then plus my b value, which in this case is 1. So it's going to be 1 over x plus 2. So what I did earlier was I took these two, got a common denominator, and we got this, right? So what this is saying is that if I start with this and I know my factors, I can rewrite it as the sum or difference of two fractions. And that's what I did. And this is going to be really easy to integrate compared to this version. All right. So it's just a way of rewriting it so we are going to be able to integrate. So this one is when we go to factor it, x squared plus 6x plus 9, we wind up with repeated factors with the same factors. That's unlike the last problem where we had two different factors, okay? But the process is really close to being the same, all right? So what we're gonna do is we're gonna factor this, right? And so we wind up with two numbers that multiply to give you 9 and add to give you 6, and that would be +3 and +3. So that means this -4x minus 7 over, and this would be x plus 3 squared, because we have repeated factors in this case. Okay, so how do you break this up? Well, what happens is you have to include every possible factor you could have for this denominator, okay? So one of the factors could be x plus 3. So we're going to write a over x plus 3, and then plus b over x plus 3 squared. So you could have either, the denominator could either be x plus 3, or you could have a fraction that has x plus 3 squared in it. Okay, so if we had repeated linear factors of like 3 of them, then we'd have to do x plus 3, x plus 3 squared, and x plus 3 cubed, and we'd have plus c. And you're going to see that in a minute where we have like 3 factors for the denominator. All right. So once again, what we want to do is we want to clear out our fractions. So to clear out all of these denominators, I'm going to need to multiply by x plus 3 squared. So when I multiply this left-hand side by x plus 3 squared, we have -4x minus 7 over x plus 3 squared equals, okay, and then this first fraction would be a times x plus 3 squared over x plus 3, and then plus b times x plus 3 squared over x plus 3 squared. And remember that really what I'm doing is multiplying both sides by x plus 3 squared, right? And this, why is it with both these? Well, because I'm really distributing it and not, I'm skipping that step and I'm distributing it. And it goes with this one. I need to multiply this one by x plus 3 squared and this one by x plus 3 squared. Okay, so that's what I'm showing here. Okay, so what happens here? Well, we're left with just negative 4x minus 7 equals, here, only one of these x plus 3's cancels. So we're left with a times x plus 3. And here, the x plus 3's cancel. So we're going to be left with plus just b, right? So there's no way that we're going to be able to make this be 0, right? Like, okay, we can make this one fall out because we can make x be -3 and x be -3 here. And actually, that's what I want to do first, okay? So I want to let x equal -3 because I can take care of that one first. And then that's going to allow me to figure out what the b value is, okay? So we're going to let x equal -3. So this winds up being -4 times -3 minus 7 is equal to a times -3 plus 3 plus b, because there's no x to put there, right? So this is going to be 12 minus 7. 12 minus 7 is 5, is equal to a times 0, or 0a, plus b. So that means 5 is equal to b. All right. So that means, okay, we now know what this b value is, right? We just need to figure out what the a is, all right? So what we can do is, now that we know that this b is 5, I can replace it with 5 right here. And now I have -4x minus 7 is equal to a times x plus 3 plus 5. So I know that's 5. All right. Now, for here, how do we pick this? All right. We can actually pick any x value as long as this factor right here, x plus 3, doesn't equal 0. So I wouldn't want to pick x equals -3, because then that would be 0 and we'd be back to, basically we'd get 5 equals 5, because we already picked x equals -3, right? So you actually can pick any x value. All right. So we want to substitute for b. That's what we did here, right? We substitute for b. When we can't get rid of it, like we did in the last problem, we substitute for b and pick any x value. Other than the one you picked over here, x equals -3, okay? So let's just pick something really simple. Let's pick x equals 0. So let's let x equal 0, because that's easy to work with, okay? So that means this, when x is 0, that means we have -4 times 0 minus 7 is equal to a times 0 plus 3, and we have this plus 5 out here. So we'd have -4 times 0 minus 7 is equal to a times 0 plus 3, and then plus this 5 out here. This becomes -7 is equal to, this would be 0 plus 3, this would be 3, so this makes 3a plus 5. Now that's going to allow me to solve for a, so I'm going to subtract 5, and that's going to give me -12 is equal to 3a, or -4 is equal to a. So now I know my a, it's -4. So that means I can rewrite this expression right here. So I can rewrite -4x, slide it up a little bit. We can rewrite -4x minus 7 over x plus 3 squared is equal to my a, which is -4 over x plus 3. And then plus my b value, which is 5 over, and this would be x plus 3 squared. And so if we add these two together, we'd wind up with this expression right here, okay? Now, if this second fraction, if the a or b, whatever you're calling this, in this case b, if it came out to be negative, then I'd want you to write this, instead of plus a negative numerator, I'd want you to write minus right here, And just like if B had come out to be -5, I'd want you to write minus and then 5 up here, okay? All right. Okay, next problem. All right, so what if you have 3 distinct factors, right? Okay, so, and this has already been factored for you, but you could rewrite this as -5x squared minus 36x minus 31 all over, and you'd have x plus 2 times x minus 5 times x plus 3 equals, and so we have only one of these each, right? So we'd write a over x plus 2 plus b over x minus 5 plus c over x plus 3. And so what we'd want to do next is I'm gonna show you what we would do if what we'd want to do is the same thing we've been doing, is multiply and clear out all these denominators. So I'd want to multiply by all 3 of these factors, both sides. So when I multiply this left-hand side by this, we'd be just left with this numerator. So we'd be left with -5x squared minus 36x minus 31 is equal to, and then here we would have the x plus 2's would cancel, and I'd be left with a times x minus 5 times x plus 3. And then plus, and then I'd have to multiply this with this one, and my x minus 5's would cancel, right? And I'd be left with b times x plus 2 times x plus 3. And then plus c, and I'm multiplying by this, so my x plus 3's would cancel this time, and I'd be left with these 2 factors multiplying with c. So plus c times x plus 2 times x minus 5. So then, like, we'd want to pick like x equals 5, because this would be 0. This we'd have something, and this would be 0. So we'd only have this plus b times, and we put 5 in here and 5 in here. So it's really the same process. I'm not going to go through this and do each one, but then we'd want to let x equal -2. And then these 2 would drop out, and then we would be able to get our a value. And it doesn't matter which one you pick, okay? If you pick x equals -2, then these 2 are going to drop out, and you'd be finding a. If you pick -3, these 2 would become 0, so these would drop out. That would allow you to find c, okay? And then again, if we let x equals 5, then these 2 would be 0, and that would allow us to find b. And you don't have to find a, then find b, then find c. You just have to find all 3 of them, okay? So we got to realize that, okay, you just got to pick, if you pick one of these, the other 2 are going to drop out and become 0, okay? So what we would have if we picked x equals 5, we would have -5 times 5 squared minus 36 times 5 minus 31 is equal to, and so this would be 0 right here if x was 5, so that's going to be gone. This one's going to be gone, so I'd be just left with this, so equals b times, and if we put 5 in here, that'd be 7 times, and then 5 plus 3 would be 8. And you would definitely probably use a calculator to figure this out, and you pick up your b, okay? And so we would let x equal -2. I mean, we would solve this, okay? So I want to say that, right? So x equals -2, that would be -5 times -2 squared minus 36 times -2 minus 31 is equal to, so if x was -2, we would pick up this one, right? So this would be a times, and then -2 minus 5 would be -7, and -2 plus 3 would be 1. And this one would be 0, and this one would be 0, so those would be gone. And then we would solve that for a, and then we would let x equal -3. And if x was equal to -3, then we would get -5 times -3 squared minus 36 times -3 minus 31 is equal to, and this would be 0, and this would be 0. And we'd be left with C times -3 plus 2, which would be -1 times, and then -3 minus 5 would be -8. And that would allow us to figure out what the C value is, okay? So we're not going to work through this. You're not going to have one with 3 factors, especially on the AP exam, okay? The most you'd have is like 2, okay? So I want to practice more with 2. So like, that's why I'm not spending a lot of time, but the process is really the same. Even if you had 4 factors, it'd be A, B, C, D, and you go through the same thing, okay? What if you have more than 2 factors and you have repeated factors? So let's talk about that next. So setting up this one, we have a repeated factor here, right? So what we're going to need to have is a fraction with just one of them and a fraction also with 2 of them, okay? So this one we would set up, and I'm just going to set it up for us. Okay, so -x squared plus 20x minus 54 over x plus 1 times x minus 4 squared is equal to, and we'd have a over this single factor of x plus 1, and then plus b over, and then we would write our single factor of x minus 4, so just to be x minus 4, and then we have plus, and then c, and we do the squared factor, so x minus 4 squared. All right. And so you could find, by clearing out your fractions, you could find the values for A, B, and C like the last one. Okay. And then for this one, same idea. We would have 5x to the 4th plus 3x cubed plus 50x squared plus 17x plus 125 all over, that's a big polynomial, x times x squared plus 5 squared. So we have a single factor with x right here, and then we have a double factor right here with x squared plus 5. So this would be a over x plus b over, okay, so the single factor of this squared, so x squared plus 5, and then plus c over x squared plus 5 squared. Now, if this had turned out to be like x squared plus 5, and then let's say this is cubed, we would have we'd have x squared plus 5, we'd have a denominator of x squared plus 5 squared, but then we'd have plus, and then we'd have a d over x squared plus 5 cubed. So you have to get each possible factor of any repeated factors like this. So power of 1, power of 2, power of 3, if this happened to be a 3. Okay, if this happened to be an x squared, we would also have a over x plus b over x squared plus c over x squared plus 5 plus d over x squared plus 5 squared. So if this was squared and this was squared, we'd have a repeated factor here and a repeated factor here. Just a little more trickier. Okay, and I'm just showing you this just in case you ever need it. All right, but for AP Calculus BC, we're really only going to look at where we have single factors down here, or we have a repeated factor but it's only twice, like examples. Really what you're going to see is examples 1 and 2. Okay, all right, that is partial fraction decomposition. That's how you do it.